Hello and welcome to your algebra recording, I meant to say, for the week of September 26th. We are also in, I should put up there, week 7. So when you go in to do your assignments, make sure you're in the correct folder this week. As always, for each recording, you should always make sure you've got a math notebook out, your math notebook, and you're ready to take good notes. Remember, you have that option of clicking pause because you are watching a recording and rewind. So you've got lots of opportunity to make sure that you're taking down good notes in your math notebook and using those notes then to help you when you go to do the graded assignments this week. So this is just one more resource to help you learn the content as well as complete the assignments in your weekly folder. So with that said, I always like to start with a warm-up question to get our minds thinking about different concepts either that we learned last week or maybe a concept that you learned last year that we're going to use again in those weekly assignments. So this week our warm-up is a handful of questions. The first question is I want you to jot down when we're talking about functions, what is the domain and what is the range? What does domain and range mean when we're talking about functions? And then for 2 and 3, you're given two different equations. And I want you, if x equals -2, to find the y for each equation below. So if x equals -2, find y for each equation below. So you're going to take x equals -2 and plug it into the equations to solve for y. So go ahead and click pause and try these on your own. And then when you're ready to check your work with mine, come on back and click play and check your work with mine. And again, try these questions on your own first. I promise you will get so much more out of this recording and so much more bang for your buck in the time that you're taking to watch this recording if you are actually trying the problems. All right, so try those warm-up problems, and when you're ready to check your work with mine, go ahead and click play. All right, so domain and range. We talked about functions last week and what makes something a function, that each input can only have one output. And when we talk about inputs, we're really talking about our x values. And that's what the domain is. The domain is all of our possible input values. And remember, our input values are going to be all of our possible x values. Whereas the range is all of the output values. So you plug a number into our function machine and it spits out an output. That's going to be your range, or you can think of it as all the possible y values that the function can have. And we're going to work more with domain and range this week, so wanted to make sure that we understand that the domain is all of our possible x values and the range is all of our possible y values, especially when we go for graphing too. All right, so if x equals -2, so we're going to be plugging -2 in to our equations and solving for y. So the first equation is that y equals x. Oops, I see an x, so I'm going to plug in -2 for x plus 8, and I solve for that. So what is -2 plus 8? It is 6. So when x equals -2 in this equation, y would equal 6. So here x equals -2, that would be our input, and our output would be 6. Number 3, when y equals 4 minus x, whenever I see an x, I'm going to plug in -2. So now I've got a double negative, which is going to become a plus sign. So y would equal, in this case, positive 6 as well. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. So this week, what concepts are we going to be learning? So we're going to continue to explore functions. We really learned already what a function is. I think we've got that down from last week. This week, we're going to look at function notation and how to evaluate functions. We're going to look at how we can write a function rule from a graph, and how to identify a domain and range, there it is, domain and range, from a graph. So, before we move on, October 2nd is a very important day for our school. October 2nd is Monday, and it's important for our school and the funding that we get for our school so that we can continue to offer online classes and our school. So it's important that we get some help from you on October 2nd, and really we're not asking for anything more than you already do. On October 2nd, just make sure you log into your online class or classes if you're taking more than one, and then be sure you complete an assignment as well in each of your classes. So I am going to have a special assignment that you need to complete on next Monday, October 2nd, and it's only going to be released on October 2nd. So just a heads up that I will have an assignment available for you on October 2nd that you do need to complete on October 2nd, and that will be in your Week 7 folder. Just a couple friendly reminders about taking notes. I think I already talked about this enough. And then really reminder to be patient when you submit late work or redos. I am getting a large volume of late work and redos submitted at this time, so it is taking me a little bit to get through those, but I promise I will. And if you want to have your assignments graded the quickest, just make sure you get those submitted on time, because my priority is first to grade the current assignments, and then I start going back and grading redos and late work. So just a reminder about that. And let's dive right in. Let's keep going with that theme of domain and range. So domain, remember, is our possible x values, while the range is our possible y values. And what we're going to do is we're going to, this week, look at how we can find the domain and range from a graph. So let's try and do that. So first it says, what is the domain and range of the function graph below? Let's focus on the domain first. So let's focus on the domain, our possible x values. So right here we've got a graph of a function. It goes from here to here. And the domain, again, is our possible x values. So what are our possible x values? And remember, the x values tell us our horizontal, right? Our x values are always those horizontal. It tells us to go left or right when we're on the coordinate plane. So what can our possible x values be? So I'm looking and I see that my graph goes from here in terms of the x values to here in terms of my x values. So we're not talking about the y values yet. We're only focusing on what the x values can be. So it looks like our x values can range from -3. So they can go from -3 to 2. So now let's write this with so that's the range, right? Our values can go from -3 to 2, but in math we want to use correct notation. We want to use an inequality. And it looks like we've got a closed circle here, so we know that our range can include -3 and all the way up to 2, and it can include 2. So let's write an inequality to show that. So the domain can be all numbers. Let's rewrite this as a inequality. So x has to be greater than or equal to -3, but less than or equal to 2. And that's going to be what my domain can be. Now what about my range? The range is all of our possible y values. So the range is all of our possible y values. And remember, the range, when we talk about our y values, that's our vertical, like up and down, what can our numbers be? So looking at this graph down here, it looks like the numbers can go from here to here when we're talking about the vertical up and down that they can be. So looking at that, that's like from 1 to 4. And again, there's closed circles there, so we know when we write our inequality that it can include those. So our range, the bottommost number can be 1, but then the y has to be greater than or equal to 1. And then it looks like it has to be less than or equal to 4, and that's our range. That's our possible y values. So remember, our y values are up and down, and the x's tell us the horizontal values. So is this a function? Is this a function? Well, one way to tell, a really easy way to tell when you've got a graph, if it's a function or not, is to apply what we call the vertical line test. And the vertical line test just means that if you draw in a vertical line, it can only touch the graph in one place. And if it only touches in one place, then it is in fact a function. So in this case, anytime I draw in a horizontal or a vertical line, I did it in yellow, I only intersected the line or the graph once. So since I only intersected once, then it is a function. So we can say yes, it is a function, and we know that from applying the vertical line test, and you're going to learn about that this week as well. So a quick example of the vertical line test not working and not being a function, let me throw up another quick graph. So here is my function, or take that back. Here is my graph. So let's apply the vertical line test here. So remember, if it's a function, it will only intersect the line in one place. So here's my vertical line test. Oops, I intersected in 2 places. So because I intersected in 2 places, this would not be a function. So the vertical line test, when you intersect your graph with a vertical line, if it only intersects in one place throughout the entire graph, then it is a function. And you'll learn about that this week. I'm going to go on to the next slide now. Functions. We learned about functions last week where in order for a relation to be a function, each input can only have one output. So let's talk about function notation. So function notation is just a kind of a different way to write an equation. So instead of writing an equation like y equals 2x, instead of writing y equals 2x, we're now going to use function notation. And I have f of x, that's how you read this, f of x equals 2x. f of x equals 2x. And let's look at what all these notations mean. So this f in front of the parentheses and the x, f is the name of the function. We can have g, we can have h, we can have f, we can have m, but f, just whatever the letter is in front of the parentheses and the x, that just tells us the name of the function. Sometimes there might be more than one function we're working with, so you might use different letters. X in the parentheses tells you what the input is. What are we putting into the equation? And then over here, this tells us the function rule, and it also, all of it is going to be the output over here that we get. And we're going to look at evaluating functions in the next slide so that you have a better idea of what I'm getting at here. So let's look at how we can evaluate functions. So here we've got a function for f of x equals 5x. I want you to find f of x when x equals 6 and x equals 2. So we're going to do this twice. We're going to find 2 different outputs because we have we have two different inputs, which means we'll get two different outputs. We're going to do it one at a time. So here's our first input, when x equals 6. So whenever I see an x, I'm going to substitute it with 6. So f of 6, this is my input. Remember, this represents the input right here. So when f of 6, whenever we see the x, we're just going to substitute in that 6. So that means f of 6 is equal to 5 times 6, which equals 30. So we could say the f of 6 is equal to 30. This is my input, and this is my output. This is my input, and this is what I get, my output. And then we're going to do it again. It also says to find f of x when x equals 2. Let's do it again. So our input value is 2. Remember, the input value always goes in the parentheses. My function rule is 5 times x. So in this case, we're going to do 5 times 2. 5 times 2 is 10. So when we have an input value of 2, the output value is 10 when we apply that function rule of 5 times x. That's how we find and evaluate functions. So sometimes the directions might be written like find f of x when x equals 6 and x equals 2. Or sometimes they're just going to say, here's our function rule, f of x equals 2x minus 1. Now find f of 5 and f of 2. So remember, the number in the parentheses, those are our inputs. That tells us, what to plug in for x. So let's find f of 5 first. So f of 5, the number 5 in parentheses tells me my value of x, or my input. So the function rule is 2 times x. Well, I'm going to put 5 in for x and then subtract 1. I'm going to continue out the rule. So 2 times 5 is 10. 10 minus 1 is 9. So the f of 5, when we have an input of 5, our output would be 9. Let's do that again for f of 2. So f of 2, that means that whenever we see an x in the function rule, we're going to substitute in 2. And then we evaluate. 2 times 2 is 4. 4 minus 1 is 3. So the f of 2, when we have an input of 2, my output is 3. So you'll get to do that this week. Evaluate functions. I'm going to go on to the next slide now, so if you need more time, go ahead and click pause so you can take good notes. All right, you're also going to spend some time writing a function rule from a table. And to do this, what you're going to need to do is look and see if you can find a pattern that relates your x values to your y values. So how do we go from x to y? So here it looks like to go from x to y, it's like either I added 0 or I multiplied by 0. Well, let's check now from 1 to 3. If I multiply 1 times 0, do I get 3? No. So that rule of multiplying by 0 must not work. What if I add 0? So adding 0 or multiplying 0 times 1 is not going to get me to 3. But, okay, so none of those rules worked that we came up with, so let's start from scratch again. Now, is there a way, how do we go from 1 to 3? So we could either add 1 plus 3. Would that work for this down here? Going from 2, if I added 2 to 2, do I get 6? No, so that wouldn't work. What is another way to go from 1 to 3? How about multiplying 1 times 3? So if I'll multiply 1 times 3, I get 3. How about apply this rule down here with the the input of 2. 2 times 3, does that equal 6? It does. Okay, let's keep going with this. Multiply 3 times 3. Do I get 9? Yes. And 4 times 3, do I get 12? Yes. So it looks like our rule, our function rule, is that if we multiply our x value times 3, we get y. Or you could say f of x equals 3x. Either way is okay. And you're going to practice that this week as well, is writing function rules from a table. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. And that's a wrap. So the week of 926 key phrase assignment, is below. So we talked about how what function notation looks like and how we evaluate functions. So what you need to do for the key phrase assignment is for the function f of x equals 3x minus 1, I want you to evaluate for f of 6. And the directions are below. If you need a reminder, if you need any help with this week's assignment, let me know. Remember, I'm always here to help. Otherwise, have a fantastic rest of your week.